My name is Adedayo, and I'm the founder and CEO of Blockops network. A little bit of background about me. I've been working as a blockchain infrastructure engineer for close to a decade now, and basically helping protocols and blockchain networks deploy and manage their blockchain infrastructure. And that's basically what led me to starting Blockops, which is a platform that makes it extremely easy for anyone to deploy and manage their blockchain nodes, and which is also what led me to what I'll be talking about today, which is autonomous node operator. But before we get started, by a quick show of hands, how many people here have tried to deploy any form of node, whether an RPC node, or a validator node, or a relay chain? Awesome. So that means you guys can relate to this. Previous slide. So that means you guys can relate to this. This is basically what the life of a node operator looks like today. It's a life full of chaos. Next slide. It's a life full of chaos, full of babysitting servers, manually running upgrades, waking up 3 a.m. in the morning, trying to fix something around the node. And the worst case of all is around validator slashings, right? Sometimes you wake up and your validators are being slashed. But for a brief context for people that are not technical here, I'll quickly explain what a node operator is or what they do. A node operator is basically the engineer that is responsible for managing the life cycle of a blockchain software. You see, when we talk about Polkadot or we talk about Ethereum, they are all blockchain software, running in a decentralized form, right? So a node operator is basically the engineer that is responsible for managing this blockchain software. And this blockchain software, they're responsible for doing 4 major things, among other things. The first thing is they secure the chain, like we all know, and then they uphold consensus, and then they provide us access to the blockchain, right? And then they validate transactions. So a node operator is meant to manage the software, the blockchain software, or the world computer that does this. However, like I said, this role is faced with a lot of this chaos. But if it was just about the node operator itself, if this chaos was about the node operator itself, nobody really cares because they are getting paid a huge amount of money for it. But the problem is that this is not just about the node operator. This is about how it affects the entire value system in the on-chain economy. For every failures, for every misconfigurations a node operator have, billions of dollars are lost on-chain. A lot of us might think that most of the losses that happens on-chain is just due to hacks. There is a secondary factor, which is misconfigurations from node operators. As a matter of fact, a lot of downtimes, a lot of losses that we have outside of hacks, and the one even due to hacks, are due to node operators, errors, or misconfigurations. So this led us thinking, like I said, this affects not just us, not just node operators, it affects protocols, it affects infrastructure providers, it affects ecosystems as well. And this led us to thinking, especially for us as an infrastructure company, running nodes for more than 100 protocols, we started thinking, how can we solve these problems? And we started asking ourselves a couple of what ifs. What if we can have a self-sustaining blockchain node? What if we can actually have an AI agent that automatically and autonomously run a blockchain by itself? And then we start thinking, what if we actually have a self-governing protocol? What if we have a self-healing protocol? And not just that, what if we actually have a blockchain node that can actually predict errors and fix them right before it happens? And this led us to building something we called Node Operator AI. Next. Yeah, we decided to building something we call Node Operator AI, and the way we envision this is going to be the coordination layer for the network, for the future of Web3 infrastructure. Next. And this is basically Node Operator AI. It's an agent that can autonomously deploy and manage blockchain nodes by itself. Think about for people that have already talked about trying to deploy a node, think about you trying to deploy a node, but think about an agent deploying a node by itself. And now, next. Now, again, like I said, Nodeoperator AI doesn't just do that. It replaces all of the toil we currently face, all of the human errors we currently face. It replaces it and autonomously deploy agents by itself. Internally, we've started doing this for ourselves because we were incentivized to reduce toil for ourselves and try to create a more efficient ways for our node to maximize return. And this is where this is very important. And this is why this matters to the on-chain economy. When you think about yield, everybody's talking about yield. But have you ever asked where are these yields coming from? Most of these yields are coming from validator nodes. These are validator nodes that perform all of the functions I talked about, and then they get rewarded by the blockchain itself. So like Polkadot, has some incentive mechanisms that reward each software for doing the work. So technically, the amount of yield that you get on chain is directly proportional to the performance of your machine, of your validator nodes. And for us, because we wanted to maximize our yield, most nodes running out there today perform at less than 90% efficiency. Think about the amount of money that is lost because of that. And for us, we wanted to maximize that, and we figured, how can we actually get our machine, our validator nodes, to run at 99.999% efficiency? And this is what led us to building Nodeoperator AI. And currently, these are its capabilities. And it's very interesting the way we build this. First of all, there are two components to this. I'll still talk about how, but there are two components to this in terms of the capabilities. Our agents were specifically fine-tuned on protocol code bases, docs, basically protocol corpus, right? So think about Polkadot SDK library, all of the libraries, OpenGov conversations, all of the palette. Our agent is specifically fine-tuned on this. He understands everything much more better than the baseline LLM does, and can easily get all of this information better. And for us as well, as a Web3 infrastructure company, we've built tools over the time. We've written infrastructures as code tools over the time that has helped us perform better than the average node operator. So what we've done now is we fine-tune an LLM on this, and this LLM is now specific to each protocol. So think about it as a specialized protocol engineer or a specialized protocol node operator for Polkadot. This guy knows much better than any random person. Think about the senior engineer in your team, right? This guy knows much better than him. And the good thing about this is now it's easily accessible to everybody, right? And part of the other capabilities, which is also what we have experimented and tested around, is now our validator nodes now perform at 99%. Right now, 99% efficiency, and we are looking at 99.999% efficiency. And also, another interesting part about Nodeoperator agent is it also serves as a technical support agent. So think about, for developers or bleeders on Polkadot, think about every time you've had issues and you've had to go to Discord channel to talk to protocol teams around some errors you're facing. The interesting thing about our agents now is our agent also has a technical support for whatever it is you're bleeding, and can easily answer questions and solve issues for you even before the protocol team does, thereby saving time for protocol teams as well. And also, at the end, this now also save money for the entire team, for the entire ecosystem. I believe even for Polkadot, there's a certain amount of money that is dedicated by OpenGov bounties just for infrastructure providers. But think about how much we'll be able to save just by using agents to do half of this work. Next slide. Yes, so this is an example of Nodeoperator AI doing work for us. This is actually a live, our Polkadot RPC archive node. So what this does is our agent acts as an employee. And anytime there's like a client release on Polkadot, it tells us, we don't even need to check, we don't need to wait on Discord. It tells us there's a client release, and it goes ahead, it gives us a summary of the release. It goes ahead and tells us about what it changed and creates a PR for it. Now, the PR is an intentional part of it because nobody would trust an AI agent to its entire infrastructure all at once, right? So that was why we created a human in the loop interface, which is basically a PR reviews. So the agent doesn't just go ahead and deploy stuff or change anything. For every actions, it creates a GitHub PR that anybody in the team can now review and approve. Currently, the agent doesn't manually do deployment. So once you approve and you merge, we expect your CI pipeline to do the deployment. Next. So now we are looking at the future where we move away from node operators running brittle automated scripts. The crazy thing about it is protocols write automated scripts, but half of the times they don't work. But right now we are going to have serverware blockchains that write script that is going to work by itself and automatically fix itself. So yeah, outside of all of the jargon I just spoke, how does this work? So there are different levels of complexities to how it works. So I decided to break it down into 3 different levels of complexities. The easiest is thinking about it in 2 manners. There is the client server, and then there is the agent core, which is the brain of the agent, right? So the client server is basically open source. We are going to release that soon. It's open source for anyone to download and look into it. Currently, we support 2 interfaces, which is a terminal UI and Slack integration, like I just showed earlier. We are looking to integrate more GitHub comments and Discord, but that's for the client side. And this is where the most interesting part of it happens, which is the agent core. So the agent core is where the reasoning model lives, is where the verifiable compute, and then the marketplace orchestration. I would explain this last 2 in a couple of minutes. Next. And this is another level of complexity to understand how our agent works. And like I already explained earlier, the agent core is being fed information from the protocols and then also from the infrastructure, which is from our end. So like live information is being fed to the agent. So the agent is learning every day. And we have also built, because of all our corpus in the past, we've also built like hundreds of MCP tools that is available for the agent to use. So think about trying to figure out whether his node is syncing, or you are trying to figure out whether a network is down or not, or you are even just trying to figure out the sync percentage for nodes, or you are trying to even figure out the attestations for validators and whatnot. So we've built a lot of MCP tools around this, and of course, this is interface, right? So the interface is where you prompt the users. We have a security level, different security levels around this. I'm also going to talk about this. So the first is the basic, Llama firewalls. But the interesting part about our agent core is that it's running in a secure environment, which is in Fala's compute environment. So we've currently partnered with Fala to run our agent core in a trusted execution environment. So the important reason why we did this is we don't expect people to randomly just give agents and trust agents to do, or trust agent blindly to just do anything, right? We expect that, next. So we expect that there will be a level of questions around how do we actually trust that the agent is doing what it's meant to do. But I'll get to that later on. Next. Yeah. So this is much grander overview of what our node agent looks like. We have the integration layer. We have the security middleware. I think this is the most important part of the work for us, where everything the agent does goes through confidential computing and can be verified by anyone and by another agent as well. And then we have privacy filters as well. And the interesting thing about the privacy filters is that as part of our works before, we already have a privacy-preserving observability tooling that we already built in-house. So basically what we did was to introduce that in here. And then, of course, these are basic Web 2 security implementations. So what we then have is also the infrastructure layer and then the core services. And these are the other interesting part of it, right? So like I said, the protocol agents are specialized agents on each protocol knowledge base. So think about Polkadot's agent, specialized knowledge on how to deploy Polkadot nodes, specialized knowledge on how Polkadot CLI works, on how all of the arguments works. But then we now decide to break them down into sub-agents So think about all the parachains on Polkadot. So think about Hyperbridge. So we now have like Bridge Agent or Moonbeam Agent. So Bridge Agent is now also specifically specialized on Hyperbridge. He understands how Hyperbridge works. He understands how to also build SDKs on top of Hyperbridge. So this is sort of like a grander view of that. Next slide, please. So yeah, together, all of this I talked about makes up the self-orchestrating brain of the agent core. And this is how our agent becomes autonomous. As of today, it's not autonomous. It's basically an agent. So you have to like prompt it to do stuff for you, deploy nodes for me, fix these issues for me. But the feature we are looking at is a feature where we don't have to prompt this at all, and it just does this by itself. Now, the interesting part of this, the economic model. Now, all the things I've talked about could just be a protocol agent or an infrastructure agent. But there's an economic model for this, and this is how we figure we are going to change or create an alternative economic model on Polkadot. Next slide, please. So we are building something in addition called the Agent SDK and the Agent Marketplace. So what the Agent SDK does is it gives people or anyone else the ability to build better agents on top of our infrastructure. So think about the utility tools or other infrastructure tools that Web3 Foundation have funded in the past. Now, especially because we are moving into an era where, whether we like it or not, we are going to be using agents to support our work. Now, we are moving to a situation, to a new era where anyone else can build another agent. Think about someone building an agent that finds you the best possible yields across all validator nodes. Someone can build it and deploy it on the agent marketplace. And the interesting part of the agent marketplace is once you deploy it, anyone else can now hire the agent and use it. To put this in perspective, let's say you are a developer today that you are trying to build a parachain on Polkadot. Instead of spending and trying to get funds to hire DevOps engineers, site reliability engineers, you can actually hire a Polkadot agent on our marketplace and tell it to deploy a parachain for you, and it's going to do that. Now, the interesting part is that we have a verifier agent, and this is, next slide. So the verifier agent, so this is what the agent marketplace currently looks like. And the verifier agent will now be the one to verify that the action you ask the agent to perform is indeed done and done right. And until it's done right, till each of these agents gets paid. Right? So that's the interesting economic model we are looking to create on this. This is currently still in the works. But however, for the part of the agents, for Polkadot agent, this is live. And at the end, I'll share the link for us to request access to test it out. Next. So yeah, back to the important questions that we're going to ask. How do we actually trust that the agent is actually doing what it's meant to do, and which is why we have our agent running in Fala's trusted execution environment, right? So that means that for every action, anyone can audit it and check that this is actually just doing all the things that we asked it to do. And then the effectiveness of the agent. Now, this is a part that is sort of like a continuous improvement, right? Which is how do we trust, or how do we make the agent as effective as possible? And which is also why we have the economic model around it, which is because there's an incentive for the agent, and we are not just even creating our agent as the only agent on the platform. More people are also going to be creating better agents. So this is a competitive landscape where it's about the best agent wins, right? Anybody builds the best agent and it wins on it. And then the last part of it is the control mechanisms, right? How do we ensure that the agent doesn't go, all right, just doing other things, right? Which is why, like I said, we have the rule books, and then we also have the human in the loop. So the human in the loop is basically for every actions, you can choose, especially important actions, you can choose to, you get like a PR review, and then you can review it and approve it before anything is done. And then for the rule books as well, there are a lot of control mechanisms that can be also coded into it based on specifications. Next slide. So yeah, these are other technical architectural considerations that we looked into that I won't be boring us on, but I think I've talked about most of them. Next slide. Forward. Forward. So yeah, so we did an interesting experiment, right? And don't call me crazy. So we hired an intern node operator, right? And then we gave an intern node operator specific task, and then we gave the agent node operator specific task. And this is how the human versus the AI agent performed. To be fair, it's an intern, right? But think about how much better this can become. When it comes to setup speed, set up the nodes or anything around the infrastructure faster than the human node operator, especially when it comes to fixing issues. You cannot rely on the human to be available at all times, but you can rely on the agent to be available at all times. And then the upgrade velocity, these are like very easy benchmarks that it was very easy for you to pass. Next. And of course, this is sort of like the next phase of our roadmap. Currently, we are here. And then, of course, we are going to be launching our public beta where we have the open agent SDK and the marketplace by Q1 of next year. And then, yeah, for the rest of it, we go as based on the feedback. Yeah, I would have loved to show this demo, but I'm short of time. So thank you, everyone. Questions?